Okay, POE, we're going to be working on the 3.1.2, which is Basic Outputs Programming, and this is going to be for the VEX test bed that we did in 3.3.1. Last time we had our sensors all set up and we played around with the sensors on the inside and saw what all of the different numbers that could come along with it are, and all the different motor port configurations and the power readings for the motors. We did all of that in 3.3.1. So if you're confused about like what sensor values to use or what is what, physically, you might want to look at that first video on 3.3.1. Now we're going to focus specifically on this task main and the curly braces that are in between. We can actually input code inside this area, and you can just hit enter to make it as large or as small as you want to. There's a couple of different things that I'll try to add along as we go in there to show you some like best programming techniques or things that just make things look easier and to read and all that stuff. So the first thing that we're going to do is make sure that all of your sensors and motors are set up in the correct spots by going in there and making sure that your motors have everything set up right from the test bed, and the analog system sensors have everything right from the test bed, and the digital sensors have everything set up from the test bed. So make sure that all of those are good to go. And then click OK. And we're going to input a program in here. And we're going to go by the input program that they go with in 3.3.2. And I want y'all, like, because a lot of people see this and they're like, well, I mean, I see the words on the thing. Can I just copy and paste it? And the answer is kind of. Like, if you copy and paste it right now, you kind of lose a little bit of the value in what's going on here. So let me just go through this. The first one that we're going to input is we're going to type in turn LED off and see what's happening when I'm actually typing this out. One, if it reaches a function that is actually identifiable, it's going to highlight in blue. And it also gives you some text as it goes along to kind of guide you along the way and be like, hey, is this what you're actually wanting to type in? If you just copied that, you wouldn't be able to see it at all. So if that's the one that I want, I'm going to go ahead and say, okay, and then open my parentheses, and I'm going to input the value that we have up here. So we called it green LED, so I'm going to type in green LED, and you can see how the text kind of showed up there. I'm going to close the parentheses. So this function will actually, it should turn off the green LED. And then if you want it to go down to the next line, you're going to have to end this with a semicolon. That tells the computer that it's actually going down to the next line of text, and we can go ahead and go down to the next line of text. Okay, the next function that we're going to learn is wait, W-A-I-T. And if you look, there's a whole lot of other different functions that you can have that deal with wait. We'll get to those later. Let's just work on the wait first. And I'll go ahead and open my parentheses. The number that you put in here is how many seconds you want it to wait. So if I put in wait 1, that's going to let it wait for 1 second. And then hit enter. And then we're going to do the same thing, turn LED, but now we're going to say on, and then we're going to type in green LED. And then close parentheses and put in a bracket. Sorry, a semicolon. Okay, I want it to wait another second, so wait 1. And while you're typing this in, get a feel for what's happening with the text around. Like the text around is actually trying to give you guides on where to go. So now we're going to do the same thing. Now we could at this point, because I'm looking at it and it says turn LED off, turn LED on, turn LED off, turn LED on, turn LED off. So it's going off, on, off, on, off. Okay, so what I could do is I could keep typing this, and that is useful to us, but I also understand that we're engineers, and engineers in and of themselves are efficient. I'm not going to call it lazy, I'm going to call it efficient. So what you can do is if the next cycle is just off and on again, you can just click and drag, right click, copy, and then move to the next line, right click, paste, and it will paste the entire thing again. So it'll turn off, then on, then off, then on. And then for the last one, it says turn LED off. So I can just highlight the off command and another wait, right click, copy, and then go down to the new line, right click, paste, and it should work. Now, what this will do is it will turn the LED off, then on, then off, then on, then off every second. Okay, and to make sure that everything is actually working correctly and that we didn't input any errors or that, we don't want to start going crazy with our code, we're going to go up to the compile program and I'm going to click on it. if everything is done correctly, then it's going to show no errors. Now, it looks like I actually have things that are not correct. So there are some cases where I don't know how to write the function. So it looks like it says, hey, are you trying to actually say turn LED off with a capital O? So I'm going to change that to a capital O here, even though it did turn up in blue. So it does kind of identify what's going on. I'm going to change these to capital letters, and then I'm going to hit compile again, and those errors go away, so everything's fine. Yellow warnings mean that it's going to try to interpret what you want to do, but it might end up a little bit wonky. So ideally, you don't want to have any warnings, and you don't want to have any errors. Red lines are errors, and those can come in several different forms. Um, the syntax errors are the ones that are the easiest to spot. So like for example, if I just get rid of this semicolon right here and I've got like new line, new line, new line, new line, oh crap, and I hit compile, then what's going to happen here is it's going to say that there is a missing semicolon. This is going to come out as a warning too because it says that, well, it's not going to, it's going to automatically, like if you look down here, it says has been automatically inserted by the compiler. So it's going to assume that there's a semicolon there. So even then, you don't get an error that comes up with it. I'm sure as I keep trying to program this stuff with you guys that I'm going to get a red error at some point in time. It's just bound to happen. That is the life of programming. The life of programming is that the only working code is 100% correct. So that means that if you get errors and those big red X's show up, that doesn't mean that everything is completely wrong. Programming, whenever you're dealing with a line of code, it either works or it doesn't. So a lot of the time that we're going to be spending is not just writing the code, but going into there and making sure that everything actually works correctly the way that it's supposed to. So I'm going to go back and compile this and make sure that it has no errors associated to it. And then I'm going to go ahead and download it to the robot. And whenever I click download to robot, it will go straight to the test bed and it should do whatever you wanted or programmed it to do. So I'm going to leave that up to you guys to do this part. Okay? And then we're going to do a little bit extra on controlling a motor. So I'm just going to type in these functions down below. So I'm going to keep these, so it's still going to turn the LEDs on and off, but I'm going to add more code down here on the bottom. And we're going to use the servo motor first, and we're going to, oh, maybe I lied to you. Maybe they want us to use the project lead the way natural commands. All right, I'm going to just go down here to the servo motor first. So if you want to change the position of the servo motor, the functions that we need to do is set servo with a capital S, and then open the parentheses, and then type in the servo motor, which is, and the reason why I'm typing in servo motor is because that's what I called it up here in the motor and sensor setup. And so we're going to identify that that's the motor that we want. And then we're going to put a comma. And you're going to type in what position you want it to go to. Remember, servos don't rotate all the way around. They only go in a specific spot. So it says that it wants us to go to negative 127, which is as far in the, I think, left direction as far as it can go. Semicolon, that's going to be one line of code. Then we're going to do wait for 2 seconds. Wait 2. New line of code. Set servo. Servo motor. Oops, looks like I capitalized this up here. Servo motor. Servo motor. Comma. 0. Close parentheses. Semicolon. We're going to wait for 2 seconds. And then it also helps if you spell wait correctly. There we go. And then we're going to do it one more time. Set servo. And we're going to do that for servo motor. And we're going to go to 127 instead of negative 127. Semicolon. And then I'm going to wait 2 again. It's going to wait for 2 seconds and then back and forth. Now, next thing you want to do is whenever you get this all lined out, hit compile program and check and make sure that everything works out okay. It does look like I did it actually backwards. Servo motor does have a capital S. I thought it was a lowercase. So I'm going to change these in my motor and sensor setup. Now remember, this has to match up. So in the Project Lead the Way worksheet, servo motor is not capitalized, but whenever I set it up in motor sensor setup, this is capitalized. Whatever is in your motor sensor setup is what you should put down here. So if it says servo motor right here, that is what you need to put in here for your motor setup. And when I hit compile program, it's like, hey, everything looks good, there's no particular problems, and then we're good to go. Okay. There's a couple of other things up here where it talks about actually taking motors and controlling motors in and of themselves. So what we're going to do is I think we have to kind of make that as a different file whenever we save it. So what I'm going to do instead is I'm just going to add that down here as more code for this. So whenever this Cortex turns on, it's going to blink the LED to start. Then it's going to move the servo positions, and then it's going to keep going straight down the line, and it's going to do these functions as well too. Now there's a couple of different things that we can do, and Project Lead the Way worksheet encourages you to use the natural language option. You don't have to use natural language. There are also some other motor options that we could use. But what we're going to use is we're going to go to natural language, and then we're going to go to movement. And there's two things. It's a start motor and stop motor. Okay, start motor and stop motor are what the Project Lead the Way natural language does, and we can go ahead and use those. So if I were to type in, or you could just come over here and click and drag, and it would actually pull that function out for you. You don't have to hand type it. So this over here is kind of super handy. So if we have start motor, and all we have to do is backspace this part and type in the motor that we want it to actually run. So let's say that we want to run the left motor. I can start typing in left and then just select down here on the left motor. And then for the speed, we can type in any value from negative 127 to positive 127. So I don't know, let's just go with 50. So I'm going to type in 50 there. Okay, I can also do the same thing with the other motor. I can go start motor, and then I can move over and change this one to right motor. And the speed, let's go ahead and make that go the other direction. So I'm going to go negative 50. Okay, and now one of the most important things to consider is if you leave this code right here, I'm going to hit compile just to make sure that everything's okay. If you leave this code right here as is, then it's going to start and it's not going to stop. It's going to just keep going and going and going and going and going. So if you want it to actually stop, you're going to have to use the stop motor command, or you're going to have to give it a value of 0. Since we've already got a stop motor command, let's just go ahead and I'm going to go to natural language, movement. There's a stop motor. So I'm just going to click stop motor and I'm going to put it in there twice. Oops. Stop motor, stop motor. And we're going to change the first one to left motor. And we're going to change the bottom one to right motor. And whenever I have both of those set up, it's going to then start the motors, and then it's going to immediately stop them. So it's going to go bzz, bzz, and just stop almost instantly. If you want them to stay on for a particularly long amount of time, you need to add a wait command in between these. So I'm going to type in wait, and let's just make it wait for 5 seconds. So if I type in wait parentheses 5, that will make it wait for 5 seconds. Hit compile and make sure that everything looks okay. All right, I think we have everything that we need for part 1, 2, and 3. So let's see, I'm going to go ahead and I'm going to save this. So I'm going to hit File, I'm going to hit Save As, and instead of calling it Test Bed Template, I'm going to call it A3_1_2. And then I'm going to hit Save. And that will be our program for 3.1.2. I hope you had a good time watching this, and I'll talk to you guys later.